In this problem, we're going to be graphing radical functions. First, by using the graphing calculator, and then we're going to answer several questions below that. So to enter a function in your calculator, let me go back to the home screen. So when you turn your calculator on, you'll be in what's called the home screen. And then to type an equation in, you press y equals. We want the square root, so that's right above the x squared key, so it's the second function of the x squared key, so press second. The x squared key, you'll get square root. And then it gives me a left parenthesis already, so I don't need to type that in. Type in negative 4x, and then plus 16, and then right parenthesis. The parentheses here are to let the calculator know that that entire expression is underneath the radical, meaning the 16 is also under the radical, not just the negative 4x. I'm going to graph this in what's called a standard window by pressing zoom and selecting option 6, which is zoom standard. Gives me a window from negative 10 to 10 on the x, negative 10 to 10 on the y-axis. So I've graphed the radical function. The next thing I needed to do is, and the graph should help me, is identify the horizontal intercept as an ordered pair, and if it does not exist, write D and E. So it looks like the horizontal intercept here is 4, 0, but just to make sure that that's true, just to show you the arithmetic on this is actually pretty easy. To find a horizontal intercept, what I know about a horizontal intercept is that the output is 0. So to do number 2, to find the horizontal, I'm going to replace the output with 0, and this is what you do to find the horizontal intercept. All points on the x-axis, the horizontal axis, has an output of 0. So if I simply solve this equation, I should get an x value that matches what I saw on the graph. So to undo a square root, I apply the inverse of that and I square it. So this is, I'm just going to recopy this so that things don't get too messy. Here's my equation, and what I want to do is square both sides. So I'm going to square the left-hand side and the right-hand side. Squaring the left-hand side, 0 squared is 0 times 0, which is 0. On the right-hand side, the radical and the squaring operations cancel each other out. They're inverse operations. They cancel each other, leaving with just the radicand, negative 4x plus 16. This is pretty simple to solve. I can subtract the 16 over. 0 take away 16 is negative 16. Over here, 16 and minus 16 add together to give 0. So you'd be left with negative 4x. You could write plus 0. It's important you know that they don't really cancel. They really simplify down to be 0, and you don't need to write it. So we adopt that phrase, they cancel. Anyway, to continue to solve, the negative 4 is being multiplied, so I will divide both sides by the negative 4. And then what I will get is, again, you can say these cancel, but a better way to think of it is negative 4 divided by negative 4 is 1. And it's being multiplied by x. It's just that no one writes the 1 because it's unnecessary. So we typically just write x, and you might hear somebody saying that they cancel. Negative divided by negative is a positive, and 16 divided by 4 is 4. So I'm getting that the horizontal intercept is 4, 0. If you plug in 4 as an x value, your output is going to be 0. And let me go back to the graph, and that looks like that's correct. I see the 4 tick mark there. Looks like it would be the horizontal intercept. So I'm going to type in parentheses 4, 0. Oops, shift 0 to get that right parenthesis. To get the vertical intercept, it's actually even a bit easier. If you're looking for a vertical intercept, that's this one right here. It looks like it's 1, 2, 3. Looks like it's about 4. So, but what I know is arithmetically this is easy, and what I know is that the input on any point on the y-axis, the vertical axis, would be 0. So it's a lot like what we just did, except instead of replacing the output with 0, we are going to replace the input with 0. So let me just erase all of this and repeat, except this time replace x with 0. So if you wanted to, you don't need to use the function notation, but replacing x with 0 would look like this. Replacing this x with 0 would be negative 4 times 0 plus 16. And then that would be, let's see, 0 times negative 4 is 0. Add 16, you get 16. And the square root of 16 is 4. So we plugged 0 in as an input. We got out 4 as an output. So my vertical intercept is 0, 4, and that certainly looks like it is that way on the graph. So the graph was made it easy to identify both the horizontal and vertical intercepts, but looks can be deceiving. I really suggest you take the time to do the arithmetic and technically the algebra over here to make sure that those are the exact numbers. Now to identify the domain, the graph has really helped me. The domain really is, in terms of a graph, how far left the graph goes and how far to the right that it goes. It goes to the left forever, but it does not go to the right forever. It stops at x equals 4. So remember, with domain, I do not care about the outputs or the y values. I only care about what the x values look like of all these points. If you plotted all the points on this curve, the x values of those points would all have the condition that they are either 4 or some number smaller than 4. So in inequality notation, you'd simply just say, hey, x is less than 4, and you'd be done. But the directions were to use interval notation. So interval notation says, first give me the lowest x value that ever would be possible, and that's actually, well, there is no lowest. You can go to the left forever. So to the left forever is considered really big numbers but negative, so we call that negative infinity, comma, and then you say how far to the right does the graph go, and that was positive 4. Now I have to make a distinction. Do I use parentheses or brackets? A bracket would be used on the 4 because it actually can equal 4, meaning that that it's actually a valid point in the graph. If I was to press trace and type in 4, enter, you see I do get a y value out. So x equals 4 is part of the domain because it's an x value that gives me a real number output. So since 4 is included in the domain, we are going to put a bracket around the 4 to let people know 4 is okay to plug in. You're going to get a real output there. Now in the case of negative infinity, you always see a parenthesis because you never actually reach negative infinity, and to be honest with you, it's not even a real number. So you'll always see a parenthesis with negative infinity or positive infinity. So back over here to Math AS, left parenthesis, negative. The easiest way to get infinity is just use 2 lowercase o's, no spaces. And then the easiest way to get a bracket is the key on the 2 keys to the right of the letter P on the keyboard is a bracket. Now we're not out of the woods yet. We've just answered the first 3 questions, horizontal, vertical intercept, and the domain. We also have to use what's called this square root tool to graph it. And here's the function. We are to graph it. And it says do this by doing, it says graph the function by plotting the leftmost point or the rightmost point depending on the domain. So we have a rightmost point. My rightmost point was 4, 0, and then it goes on to say and one other point. So you might as well use the point 0, 4 since we worked so hard to get that. But suffice it to say, you could pick a different point. Like for example, I could go over here and trace, type in -4, since that's in my window here on the computer, and it would say, y is roughly 5.5, 5.6, and you could get something close. But I probably would just go to this graph and make things simple. Click on this icon, the draw command, and it says start with the rightmost point 4, 0. Click and hold the mouse. Scroll to the left. Pick any other point. Might as well use the point 0, 4 since we had that. And then you simply let go, and there's your graph.